This video is going to talk about measures of variation. Something to know about the different measures of variation that we're going to be looking at in this video is that, first of all, there's a couple of things that we're going to be looking at, and like a lot of things in 6th grade, there's going to be a number of small steps in order to complete these. And in itself, those steps are not difficult, but because it can be complicated and there's a lot of little things to remember, it might seem a little bit more challenging than it is once you start to kind of get in the groove of everything. So go ahead, take your time when you're working on this, and we're going to look at some vocab first so we know what we're talking about. Measures of variation describe the distribution of data. They describe the spread of data. They help you get an understanding for it without having to look at every little piece of it. First thing that we're going to look at are quartiles. Quartiles are values that divide the data into 4 equal parts. You have quarters, you know what those are. We're going to talk about quartiles, which are kind of like the separating part between the quarters. The 2 main quartiles that we're going to talk about today are the first quartile and the third quartile. The second quartile in data is actually just the median, but we don't call it the second quartile, we call it the median. The first quartile is the median of the lower half of the data, and we're going to take a look at what that means. The third quartile is the median of the upper half of the data. So the first quartile is the smaller numbers, the third quartile are the bigger numbers. The range of numbers is the difference between the largest number and the smallest number in a set of data, and that's the absolute value there. It's just looking at how many steps are there between the smallest and the largest. The interquartile range is the difference between the first and the third quartile. So it's the same thing as range, it's just only for the middle half of the data, and we're going to talk about what that looks like. We also have something called outliers. Outliers are data values that are much bigger or much smaller than the others. So, for example, it has to be something that is more than 1.5 times the value of the interquartile range. So that value of the interquartile range, whatever the interquartile range is, an outlier has to be more than 1.5 times that number beyond the quartiles. And we're going to take a look at what that means. So, now that we have an idea of the vocab, let's go ahead and switch over here to our first example. And our first example, this is the second example, we're not quite there yet. Our first example is going to talk about the 2012 Olympics, and it's going to discuss the countries and the medals. And conveniently, these numbers are in order from greatest to least, so that's going to help us out. The first thing that we want to figure out for this is we want to figure out the range. So I'm going to adjust the camera just a little bit. Okay, and we need to figure out the range for this. So for these, we're going to look at the largest number and the smallest number. And the largest number is 104. The smallest number is 38. So we're going to subtract those two from each other to get the range. And we see that our range is 66 because we subtracted 104 minus 38. Then we're going to take a look at what the median of this data set is. And the median here is going to be the number in the middle. We've gone over that one. So we're going to start at the top and the bottom, work our way in, work our way in. There is no exact middle number, so we have to take these 2 middle numbers and find the mean of them. So we're going to add 82 and 65 together. and that's going to be 147, and then we're going to divide 147 by 2, because we added up two numbers. 2 goes into 14 7 times. 2 goes into 7 3 times. And we're going to have 73 and a half for our median. The next thing that we're going to find is we're going to find our quartiles. So we talked before about how quartiles are the median of the lower half or the upper half of the data. So in order to get our first quartile, which is going to be written as Q1, what we have to do is we have to look at the lower half of the data. So I'm going to split this data right down the center. And my quarter 1 is going to come from this area. We need to find the median of this data. So I'm going to start at the top and the bottom. Look, quartile 1 is 44. It's the same thing as finding median, but you're not doing it with all the numbers. You're only doing it with half of the numbers. No big thing. It just sounds really big and official. Quartile 3, that number, we're going to look at the upper half of the data. So I start at the ends, work my way into the beginning, into the middle, and that number is going to be 88. So my quartile 1 is 44, my quartile 3 is 88. So now what I need to do is I need to find that interquartile range. So let's take a look at what the interquartile range is. I'm going to look at quartile 1 and quartile 3, and I need to find the difference from them. And that will be the IQR, or the interquartile range. So, what is 88 minus 44? Well, that's going to be 44. So the interquartile range is going to be 44. Now, what we need to do to check for outliers is we're going to go ahead and we're going to take this interquartile range and we're going to multiply it by 1.5. So I'm going to take 44 times 1.5. And 44 times 1.5 is going to be 66. So now what I need to do is I'm going to take 66 and I'm going to apply that to the median. I'm going to add it to the median, and I'm going to subtract it from the median. So 73 and a half, I'm going to go low first. 73 and a half minus 66. Well, that half's really not going to be affected. And I get 7.5. We're going for big numbers here. Then I'm going to take 66 and I'm going to add it to 73 and a half. And I get 139 and a half. Now what these numbers mean is that if anything is lower than 7.5, it's going to be an outlier. And we see over here that we have nothing lower than 7.5. If anything is larger than 139.5, that's going to be an outlier. And if we look up here, we see that there is nothing larger than 139.5. So for the 2012 Olympics, for the data that we have here, we don't have any outliers. Now that we've looked at this, we're going to go ahead and take a look at a different data set. So I'm going to erase what's up here in this work area, so if you need it, take a look at it right now. Now what we're going to do is we're going to take a look at one more set of numbers. We're going to take a look at the average daily temperature in a week of July. It's not July yet, but we will get there eventually. So the average daily temperatures were 71, 89, 90, 92, 92, 94, and 95. What you might notice is that these are conveniently in order from least to greatest. I did that so we could save time on the video. You always need to make sure that you put the numbers in order from least to greatest. So the first thing that we're going to find for this data is we're going to find the range. Remember that the range is the difference between the largest and the smallest number. So that would be 95 minus 71. And when we take 95 minus 71, we're going to get 24. So the range is going to be 24. Now what we're going to do is we're going to find the median of the data. The median of this data is going to be the number in the middle. So we're going to start at the extremes, work our way in, and see that the median is 92. Remember that this is the center number. This is the number that we're going to apply that interquartile range to after we multiply it by 1.5. But we'll get there. The next thing that we're going to do is we're going to find the upper and the lower quartiles. Quartile 1, quartile 3. Now, what we need to know here is that there is actually a number in the middle. So that number does not count for the lower half of the data set. It also does not count for the upper half of the data set. Neither one of those count. So what we're going to do is we're going to go ahead and find the median of the lower quartile, of the lower set, which is going to be 89. So our quartile 1 number is going to be 89. Then we're going to find the median of the upper data set, the upper half of the data set, and that's going to end up being 94. What I need to do now is I need to figure out the interquartile range. IQR. That is the range between quartile 1 and quartile 3. So I'm going to take 94 minus 89 and get 5. So my interquartile range is 5. What I'm going to do now is I'm going to take this 5 and multiply it by 1.5. So basically take 5, add half of 5 to it, and I'm going to get 7.5. So now what I'm going to do is I'm going to go over to the median. And the median here is 92. So I'm going to go 7.5 lower than 92. 92 minus 7.5. Line up my decimal, do the whole borrowing thing. And I get 84.5. I'm also going to add 7.5 to 92. And I'm going to get 99.5. So now I have to look at my data from the beginning, and I have to see if any number is bigger than 99.5 or smaller than 84.5. So I'm looking for anything bigger than 99.5, and I don't see that. So there's no outlier on the larger half. I'm going to look for any number smaller than 84.5, and I'm going to see that 71 is an outlier. That means that 71 doesn't really fit well within the rest of the group because it is so far removed from everything else that it's just not, like everything else is high 80s or 90s, and then we've got this random 71 in there. And what we've just done is we have just proved that that is an outlier. So what you're going to do is you are going to give in your homework an obvious example of an outlier. This is something that you are making up on your own. You're going to make up a group of numbers, and then you're going to tell me what would be an outlier to that group of numbers.